Light waves. So light travels as transverse waves and is faster than sound. It can be reflected, refracted and dispersed. Ray diagrams show what happens to light in mirrors and lenses. Eyes and cameras are the things that detect light. How light travels. So light travels as transverse waves, like the ripples in a tank of water. The direction of vibrations is at 90 degrees to the direction of travel. Light travels in straight lines, so you represent a ray of light in a drawing using a ruler. Unlike sound waves, light waves can travel through a vacuum. They don't require a substance to travel through, but they can travel through transparent and translucent substances. So here's a few differences between light and sound. So light waves are transverse, whereas sound waves are longitudinal. Light waves can travel through solids, liquids and gases if they are transparent or translucent, and sound waves can travel through solids, liquids and gases. Light waves can travel through a vacuum, whereas sound waves can't. Light waves are detected by eyes and cameras, whereas sound waves are detected by ears and microphones. Light and sound waves can both be reflected, and light and sound waves can both be refracted. The speed of light. So light travels quickly. Its maximum speed is 300,000,000 meters per second when it travels through a vacuum. The difference between the speed of light in air and the speed of sound in air explains why you can see lightning before you can hear it, why you can see a firework explode before you hear it, and why you can see a distant door slam before you hear it. So you see light before you hear what's made the explosion, because light travels a lot faster in air. Reflection. A ray diagram shows how light travels. In a ray diagram, you draw each ray as a straight line, with an arrowhead pointing in the direction that the light travels. You should always use a ruler and a sharp pencil. The law of reflection. So the incident ray is the light going towards the mirror, this one here. The reflected ray is the light travelling away from the mirror, this one here. And then the hatched line here represents the mirror. And then the dashed line here represents the normal, which is 90 degrees to the mirror. The angle of incidence, or I, is the angle between the normal and the incident ray. The angle of reflection, R, is the angle between the normal and the reflected ray. The law of reflection states that the angle of incidence is equal to the angle of reflection. The angle of reflection is 30 degrees if the angle of incidence is 30 degrees. The angle of reflection is 90 degrees if the angle of incidence is 90 degrees. And if a light ray is travelling along the normal, so like this, it's just going to reflect back the way it came. The reflection of light from a flat surface like a mirror is called specular reflection. And specular reflection is where light meeting the surface in one direction is reflected in one direction. You can also get scattering. So if light meets a rough surface, each ray follows the law of reflection. However, the different parts of the rough surface point in different directions. So the light is not always reflected in one direction. The light is in fact reflected in all directions, so lots of different directions from the rough surface. And this is known as diffuse scattering. So diffuse scattering is where the light is scattered or reflected in all directions.